So today we will be learning about vectors, and in this video we will cover about addition and subtraction of vectors and multiplication of vectors. But before that, I want you guys to differentiate between scalar and vector quantity. So scalar quantity is a physical quantity which is represented by a single real value, or also known as magnitude only. Vector quantity is just like scalar quantity, but we have direction. For example, if we have a car, we have this red car, and we say the car is moving at the speed of 5 kilometers per hour. So this speed is the scalar quantity of this car. So it moves at 5 kilometers per hour speed. But for vector, we will say that this car moves at 5 kilometers per hour of speed to the right. So this will be your vector quantity. So scalar quantity can be anything as long as it has a real value and it is a physical quantity, such as we have heights, temperature, and last but not least, of course, we have speed. Meanwhile, for vector quantity, we have velocity, or just anything that have direction in it. So for example, I walk 5 kilometers to the north. So this is our vector quantity. So in mathematics, we use vectors in order to show how far does an object move and where it is going. For example, we have this Cartesian plate, and we have 2 points here, point A and point B. So as we can see here, we have 2 points, that is point A and point B, and we can see that the object moved from point A towards the point B, and we use vectors in mathematics in order to show how many units does object from A move to B. And there are a few ways to write this vector, and one of them is using the displacement vector. That is, we have the capital letter that represents the points, and we have an arrow up here to show that it moves from point A to point B. So another way to write down a vector is by using a small letter that represents the journey that the object has passed through, instead of using 2 points just like the above. And usually we have the small wavy thing below the letter that we call as tilde. And also for printing or digital writing, we use the bold print, something like that, that have, you know, thick So there are two types of vectors, or for at least that I know. So we have the displacement vector, and also we have positional vector. So both are pretty similar, but it's totally different. So let's look at the displacement vectors. There are many vectors that fall under this category, and one of them is like the chances of you getting beaches, that is 0. So we have 0 vector, which means that it is indeterminate, or in Malay we call it as tak tentu. For example, we have point A and point B, and the object goes like this, and yeah, this is not vector. A vector needs to be straight, and this is not straight, so it's not a vector. Or when you have a point A and point B, and the object doesn't move at all, okay, which means that its magnitude AB is equal to 0. So it is called a 0 vector. So next we have opposite vector. So for opposite vector, the magnitude are always the same, but the direction is not equal. Next we have equal vectors, and this vector is kind of similar to opposite vector, whereas the magnitude is the same, but this time the direction is also the same. For positional vector, it involves the Cartesian plate. As we can see, the x, we have x-axis and y-axis, and the movement of the object that move along the x-axis is represented by the letter I with the tile below it, and the movement across the y-axis is indicated by the letter J with the tile underneath it. So let's say I have a point A here, and this right here will be called as point O, or also known as the origin point. So from the point O to point A, I can write it as A in a small letter with the tile below it. So this is the use of the positional vector, where we can use it to determine how far and where does the object move, whether it is moving to the right or left, and also whether it is moving up or down. So imagine we have a car here, right? So this is where the positional vector is playing a role. So this car is moving from point O to point A, and using positional vector we can determine how much does it go right and up. Because without positional vector, and if we use displacement vector, we don't know where does the car move, whether it is to the right or to the left. It also can go up, fly, I don't know, it can be anywhere. So this is why positional vector is very important. And also there are two types of positional vector, that is 2D and 3D. So for 2D, it is called as, of course, two-dimensional, or also known as the coplanar vector. And for 3D, it is called three-dimensional, or also known as the space vector. So both are different, but also similar in a way. So there are two ways in order to express positional vectors, and one of them is by using column vectors, where we express in terms of matrix P and Q, where P is our x-axis or I, and Q is our y-axis or J. And don't forget the tile. And the other ways to express the positional vector is by using the linear combination that we learned earlier, that is I and J. So we write it just like the linear equation, but this time instead of using x and y, we use I and J. So let's say I walk 4 meters to the right and fly 10 meters up. So we can write it as 4I, which means that I move or I walk 4 meters to the right, plus 10J, which indicates that I fly 10 meters up. And don't forget the tile once again, please. So the same goes to the 3D vector or the space vector, except we have an extra variable that is P, Q, and R, where P determines where the object move forward or backward, and Q right to left, R is the up and down. So it's just the same as the coplanar vector, but this time we have an extra step, you know. And also for the linear combination, we have an extra letter that is K, which represents the z-axis in the Cartesian plate. So let's say I move 4 meters to the right, 2 meters backward, and fly 5 meters up. So we can write it as -2I plus 4J plus 5K, which indicates that I move backward 2 meters, and I move to the right 4 meters, and I fly 5 meters up. Alright, so now let's move on how to find the magnitude of a vector. Move. Alright, so basically magnitude in vectors are used to determine on how far does the object actually go. So before this I told you that I move 4 meters to the right and 5 meters up, but you don't know how much exactly do I move. And as you can see, from point O to point A and to here, it forms a right angle triangle. in order to find how far did I exactly go, we need to use Pythagoras theorem like we used to learn before. And as we know, the formula is a squared plus b squared equals to c squared. And let's apply this equation in our topic today. So the magnitude of a vector, let's say vector A, is equal to square root of p squared plus q squared. And the same goes to the 3D vector, and the equation is a squared plus b squared plus c squared is equal to d squared. And let's apply this equation into our vector. We will get vector of A, let's use B this time. So vector of P is equals to square root of P squared plus Q squared plus R squared. Okay, so now let's look at for some example question regarding this topic. Alright, for the first question, it wants us to find the magnitude of the vector A equals to 5i plus 12j. Alright, for the first question, it wants us to find the magnitude of the vector A equals to 5i plus 12j. And like I said, it wants us to find the magnitude. So magnitude, like we just learned just now, magnitude of A is equal to square root of P squared plus Q squared. So this is our P and this is our Q. So P equals to, so the magnitude of A is equals to square root of P squared, so 5 squared plus Q squared, and our Q squared is 12, so it will become 12 squared. So put this value in your calculator and we will get 163. Square root of 163 and square root of 163 is equal to 13. So, and don't forget the unit, that is 13 units. So this is how we get the magnitude of a vector. Alright, so for the next question, it says find the unit vector in the direction of vector A equals to 2i plus 2j plus k. So unit vector, in order to find unit vector, so the formula is unit vector equals to, so unit vector is equals to our vector equation over its magnitude. So in this case, our vector equation is 2i plus 3j plus k, and in order to find the unit vector, we need to divide this equation by its magnitude. So first step, we need to find the magnitude. So magnitude A, modulus A, is equals to square root of P squared plus Q squared plus R squared, because this is a 3D vector. So we will get square root of P squared, that is 2. So 2 squared plus Q squared, that is 3. So Q is 3. Plus R squared, and our R is K, and K is also known as 1K. So our R is 1 and R squared is 1 square. So we get square root of 14, and we already find our modulus. So in order to find the unit vector, we take all this equation so this is how you can find the unit vector of any equation. So and please don't forget the tilde. Yeah, it's pronounced as tilde, not tilde. My bad. I searched it out earlier. So yeah. So moving on to the next question. So the next question, it says that given that OA equals to negative 1 plus 2j minus 3k and OB equals to 4i plus 3k, where O is the origin, find the vector and magnitude of AB. Okay, so the first step is to draw, just not to be confused. So let me just draw. So for the first point, it is located at negative I, so there is right here, and plus 2j, which means that it will go above, and minus 3k, so it will be behind, it will be on the negative z axis, so it will be about right here. And for the point B, it says that it is located at 4i plus 3k. So 4i plus 3k. So it will be right here. So it is given that OA, which means that this is point O, this is point A, and this is point O, and this is point B. So in order to find the magnitude and vector of point AB, let's say we draw a line from here to here that is straight from A to B. So what are the other way that we can go through in order to reach from A to B? Is from A to O and then O to B. So A to O, then O to B. So it may seem a little bit confusing here, but don't worry, it will be easy, trust me. So from A to O, since our original equation is from point O to A, the vector from A to O will become negative OA. So so AB is equals to negative OA plus OB. Negative I plus 2j minus 3k plus OB. Our OB is 4i plus 3k. So we will get I minus 2j plus 3k plus 4i plus 3k. So our final answer, we will get 5i minus 2j plus 6k. So this will be our answer.